Lagrange multipliers. Okay, so this is a different method to maximize and minimize. It's different. It's algebraic instead of yeah.
Calculating.
If you what we're getting for Lagrange multipliers, we are going to maximize or minimize a function subject to a constraint of this form. So we may have to rephrase the way we work the problem, but we can do some of the problems either way. Okay, so we are going to do some of the problems that we did in the previous section. For functions of two variables, we are going to find extreme values of f subject to a constraint g of xy equal k. Okay? So we need extrema for f of xy when xy lies on the level curve. Remember level curves from your last test? Okay. So I just stole a picture out of the book. Here's the geometric explanation rather. I want to maximize my function f, and f are these guys, right? Level curves, subject to g of xy equals k.
So G is the boundary.
So g is the constraint. So I want f to be as large as possible, but it's still
within the G.
within g. Still applies to g. So do we see that I must find the largest value of c such that f of x, y equals c intersects g of x, y equals k. So what is it in this case?
10.
Right here, this one, 10. C is 10. Because if I want to go further along G, I see I start to go backwards along the F, or either way I go.
Yeah.
Eventually it starts to curve backwards, so with the maximum one. Okay, so, and I kind of jumped ahead right here. That's what this is getting at. This is going to occur when the curves have a common tangent line, and that's what I mean right here. You see their tangent line right here? Okay, why am I not drawing? It's right there. Same tangent line for both. And the reason is if I continue on further, it starts to curve back on itself. The lower values of f. Okay. So normal lines at the point x naught, y naught, where they touch are identical. Does that make sense? Normal lines mean they're orthogonal. Right? So if I look at the point where they touch and I draw normal lines.
It's just like a mountain.
Mm-hmm.
There's a boundary.
Yep. So the gradient vectors are parallel, which means I can write this. The gradient of f at the point x naught, y naught equals the gradient of g, equals lambda times the gradient of g, x naught, y naught. And lambda, that's a Greek letter, lowercase lambda, it's a scalar. And this is not a vector. I'm just not very good with my marker today. I don't know what's going on. This is parentheses. Okay. So if I have three variables, I extend the argument. I just have an x naught, a y naught, and a z naught, right? It's just going to be a level surface, though, instead of a level curve, right? Y'all see the picture? I'm going to have, instead of level curves, I'm going to have level surfaces. This is like a mountain, just like Justin said. But I'll have, this is a mountain in 3D, but if I was looking at a level surface, I could still do the same thing with G. Okay. So the point x, y, z is restricted to the level surface with the equation g of x, y, z equal k. So f of x, y, z equals c are level surfaces. If the maximum value of f at the point x naught, y naught, z naught equals c, then the level surface f of x, y, z equals c is tangent to the level surface g of x, y, z equal k. And just like before, if I have the same tangent line, that means that the gradient vectors are going to be parallel. So I can write the gradient of f now in terms of three components, x naught, y naught, z naught, and that's going to be equal to lambda times the gradient of g, x naught, y naught, z naught. Does that make sense? Just like the other one, except for I added on a z, right? How do we do this? Well, I'm glad you asked.
Right.
Huh?
What is it? Matt.
To find maximum and minimum values of my function f subject to g, some function g of x, y equal k, this is what I do. First, obviously, the extrema must exist. The gradient of g can't be 0 on that surface. Okay, so the first thing I do is I find all values of x, y, z, and lambda. Now I have an extra variable, right? X, y, z, and lambda, such that, here's your equation. The gradient of f of x, y, z equals lambda times the gradient of g, x, y, z, and g of x, y, z equals k. You're going to solve equations. You have this equation and this equation. When you're doing this equation with the gradients, you're going to be able to separate it into x components and y components and z components. So do you see that? If this gradient equals a constant times this gradient, I can have an equation with x's, right? The x component of this one equals lambda times the x component of this one. That's one equation, right?
Right.
Then one with y's, one with z's, and then this guy. So I have 4 equations and 4 unknowns. I'm able to solve the system completely. Does that make sense? Okay, so then once I find values for x, y, z, and lambda, I then plug back in and find my function values at all those points. Obviously, the largest is going to be the largest of those will be the max, right? And the smallest is the min. Okay, so this is what I was saying before. If I'm setting the gradient of f equal to lambda times the gradient of g, I have f sub x equals lambda gx, f sub y equal lambda gy, f sub z equal lambda gz, and I also have this function equals k. 1, 2, 3, 4 equations and 4 unknowns. Okay, let's see if we have time to try one. This is the same problem I think we just did. Yeah. I'm going to zoom in a little bit. You know the answer already? That's amazing. What was the answer anyway? 61? Oh.
4 meters squared.
Okay, so let's set this up. I have my box. From before, I know that volume was x, y, and z, and my surface area was, it didn't have a lid, or it did? It did not. Was, let me draw the same picture. I need to draw the picture. I don't have much room, but you get the idea, hopefully. Okay, so x, y, z. I have xy plus 2yz plus 2xz, like this. And it was equal to 12. So this is the same thing we started with in the other question, right? The last section. We did it, I guess, Monday. Same thing, though, right? We are going to maximize what? Volume. So we are going to maximize f of x, y, z equals x, y, z, and that was my volume. Subject to what? Subject to, this is my g of x, right? Do you see that this is?
Wait, it should be x, y, z, right? G of x, y, z.
Yes.
And is your k 12? Since
Yes.
G of okay.
So I haven't done anything different at this point. I just said, here's my 2 equations. Now let's recognize I'm maximizing this one subject to this one. Okay, so everything is still pretty much the same thing we did last time. Last time, though, we needed a function of, we were trying to maximize this, so we ended up solving. Do you remember we solved for this z here or something, and then we plugged back in. Then we had to take a derivative, partial derivatives. And it wasn't bad. It's just kind of tedious. We had to be very careful, right? So now we are going to come up with equations. We're going to say, I'm just going to call this v of x. Okay. We are going to say v sub x equals lambda g sub x. V sub y equals lambda g sub y. V sub z equals lambda g sub z. And we know this. Oh, let me just write g. Let me just do this first. In general. Okay. So what is the partial derivative of v with respect to x? What is this partial derivative of g? What is it? Y plus 2z. I'll check. Is that right? Everybody check. Yes? Okay. V sub y is equals lambda times g sub y will be x plus 2z. Is that right? V sub z will be x, y equals lambda times
2y plus.
and then I'm just going to rewrite this guy. Okay, does everybody see what we've done so far? So we're going to put the calculus aside for now, and we're just going to solve this system of equations. There are 4 equations and 4 unknowns. So you can do lots of different things, lots and lots of different things. One thing I'm going to do is expand out these lambdas just for now. Oh, let me label them too. This is 1, 2, 3, and 4. That way I can refer, like I can do 1 times, or 2 times 4 plus 3 times 2 or something, and I can tell you, you know exactly what I'm talking about. Okay, so if I do yz equals lambda y plus 2 lambda z, xz equals lambda x plus 2 lambda z. Do you see both of these have lambda z's? 2 lambda z's, thank you. So I can put those together if I want to. So I'm going to solve 1 and 2 for 2 lambda z and equate them.
So yz minus lambda y.
Okay, hang on. So yz minus lambda y equals lambda x. Okay, y is z minus lambda. This is what I want to do. Equals x times, oh, z minus lambda.
So you're solving for z minus lambda.
So y is x. As long as z is not equal to lambda. Otherwise you're multiplying by 0, right? Integral 0 times anything is 0. It's a moot point. Do y'all see that? So y equals x. That's wonderful. That'll help me clean up a whole bunch of other things, right? So I'm going to rewrite number 3 in terms of z. I'm sorry, in terms of y or x. What do we want to do? Doesn't really matter. Do y? Or is there something else that would be nice?
Well, nice either way.
Oh, I never did clean up 3 and 4, did I? Let me do that first. xy equals 2 lambda y plus 2 lambda x. And then rewrite this guy.
So you could solve it, equate them for x, y.
You could do lots of different things. You could take the xy's if you wanted to. Oh, another thing we could do, we could solve 2 and 3 together if we wanted to. Multiply this one by y and this one by z and set them equal to each other. Or multiply this one by x and this one by y. Actually, I already did those. This one by x and this one by z. I can just pick any two, right? So I'm going to go ahead and leave this one alone for now. This is going to be my final one because there's a lot going on here. You'll see this? Okay, so I'm going to try to do something else. So what if I do, so pick one. I already did 1 and 2, so I need another pair out of these. Which pair? Solve 2 and 3. So I'm going to multiply 2 by y and 3 by z, and then I'll get xyz, xyz, and I can set them equal to each other. and equate x, y, z.
Couldn't you just pull out a 2 out of 3 and solve for lambda x?
You can do that too. You can do that too. So I get, if I multiply this one by y, I get lambda xy plus 2 lambda yz equals, can I scoot over? Okay. Equals, multiply this one by z, 2 lambda yz plus 2 lambda xz. Is that okay? I'm going to move everything to one side. Do you notice some things cancel? Gotta be real careful with my lambdas and my x's. Lambda xy, these guys cancel. Minus 2 lambda xz equals 0, right? This cancels, yes? So I'm going to factor out a lambda and what else? Lambda and an x. Okay, so I get y minus 2z, check me, equals 0. Okay, so either lambda is 0, or x is 0, or y equals 2z. Right? Okay, so I can't have x equals 0 because I wouldn't have any dimensions? Okay. So no box if I did this, right? So I'll check both of these.
Well, if lambda is equal to 0, would it make your surface area 0?
If lambda is 0,
Isn't a thing lambda g of x, y, z?
no, lambda is just the relationship between, well, yeah, then all the derivatives will be 0, right? If lambda was 0, then I'd have x and z both would be 0 here. Or I guess one of them would be 0, right? Do y'all see that or not? So can I have lambda equal 0? No. No box. Okay, so it looks like I just have this guy and this guy. So I have y equals x, as long as z is not equal to lambda. And I have y equals 2z. And I still have, I really haven't used equation 4 yet.
X equals 2z as well.
Yep. So I'm going to rewrite G. If you're doing this on your paper, there's lots of different ways to go about this. I just picked a way and just went with it. Okay, so if I plug in a substitution into here, will that help? Which way do you want to go?
All the y's and z's can turn into 2z's.
So you're saying y is 2z and x is 2z, yes?
Yeah.
Is that what y'all want to do?
Well, you could just plug in for y.
Plug in y equals 2z and x equals 2z into number 4. Then I have an equation just with z's. Okay, check me. I get 4z squared plus 2 times, I got to do it like this, plus 2 times 2z times z. Yeah, but if I do it in my head, I lose a piece. Is that okay? That's a 2.
So it's going to be 12z squared divided by 12.
Z is plus or minus 1.
Hang on, what? This is 4, oh, you're saying I have 4z squared plus 4z squared plus 4z squared equals 12, so 12z squared equals 12, z equals plus or minus 1.
But you can't have negative 1.
Yeah, so you can't have a negative sign.
So, that one's out.
Z is 1.
So if z is 1,
Y is 2, x is 2.
that means x is 2, y is 2 meters, and z
Now
is
find
1
lambda.
meters. We can find lambda, we don't have to, because it's not really part of our answer. Sometimes I've done problems where maybe it wasn't as obvious to me how to solve, and maybe maybe lambda was equal to 5, or x is equal to 3. So I plugged in x equal 3, and also plugged in lambda equal 5, and found the other x, y's, and z's values. So we found a lambda value here that we threw out because it didn't give us a box. But I have had situations where I found lambda first and used it to find the other variables.
So lambda can't equal 0.
In this situation, no, because it's a real world situation. But if this was just maximize this in terms of this and you didn't know that it was a box, sure, it could be 0.
Yeah.
But what happens to Z not equaling lambda? You have to write that or not?
No, I mean, no, not in this. Because it didn't ask me in terms of lambda if I was finding lambda. So lambda can't be 1 then, right? So, but it doesn't matter for our problem. So the question said maximize the volume, so the maximum volume is 4 meters cubed. Does that make sense? How do we feel about this? You like this better or the other way better?
This way better.
Algebra better. You don't like the calculus?
I like this better. I haven't even seen the other way yet.
The calculus can get really tedious with those partial derivatives, right? Let's set up another one. We may not be able to finish it, but let's just see. Okay, if I can turn the page. Okay. I'm going to zoom in a little bit. Okay, read this to me.
Find the extreme values of function x, y, capital.
Why is z capitalized? I need to fix that.
2x plus 6y plus 10z almost 3x squared plus y squared plus z squared plus 35.
Okay, it says find the extreme value, so I want a maximum value and a minimum value, okay? So I'm going to maximize and minimize this subject to this. So I'm going to maximize and minimize f of x, y. I'm not going to write it out. Subject to this. I'll write it out in a second, but y'all see what I'm saying? You always want to identify. What was hardest for me as a student is sometimes I'm like, wait a minute. I got so used to doing it the other way where I make a substitution and use one in terms of the other, you know. I'm like, wait a minute, which am I maximizing and which is given to me? So sometimes it's not as obvious. You know, here it is. But okay, so then I want my partials. F sub x equals lambda g sub x. So that is
2x
equals lambda times
2x.
okay. F sub y equals lambda g sub y.
6 equals lambda 2y.
2y. Yeah, 2y. F sub z equals lambda gz. So 10 equals lambda times 2z, and then I write this guy. This one's a whole lot easier to solve, right?
Yeah.
X is, well, let me get up with it. This is
X
2
is plus or
equals
minus
2
1.
lambda x. So 1 equals lambda x. Yes? Okay, let's just do this for a second. So then 6 equals 2 lambda y. So 3 equals lambda y, right? And 10 equals 2 lambda z. So 5 equals lambda z. So it may be easiest here to solve for lambda and then sub back in. Because I can solve x is 1 over lambda, but there's nowhere to put it. I guess I could do x is 1 over lambda, y is 1 over 3 over lambda, and plug into here. How do you want to do it? Solve for lambda? Okay. So lambda here is 1 over x, and we know that x can't be 0, right? And then 3 over y is lambda as long as y is not 0. Is that right? So 1 over x equals 3 over y. Y equals 3x. Da, 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 da. Right? And I can do the same thing here. 5 over z equals lambda as long as z is not 0. And set any of these two together. Which ones? Doesn't really matter.
Let's use y.
Y. So 3 over y equals 5 over z. 3z equals 5y. So y is... No, wait, I want to do, wait a minute. Every time I see a y, I'm going to replace it with x. I should have solved the other way around.
So z is equal to
If you
5x.
just-
Or I could do a fraction. You know fraction here?
No, if you just solve it for y, then you can say 3x is equal to whatever you do.
3/5 z equals y. So
Or
3x equals 3/5 z.
So 15x equals 3z.
So 15x equals 3z. So 5x equals z. Okay, so I can plug this and this in, and both z and y are in terms of x. Sometimes it's getting a little hairy sometimes. Okay, so I have x squared plus y squared is 3x squared plus 3/5, no, just kidding, wrong one. 5x squared plus equals 35, check me. Do silly things sometimes. So I have 9 plus 25 plus 1.
35.
So what is it, 35? X squared equals 35. So x equals 1 or x equals -1. Am I allowed to have positives and negatives here?
Yes.
Sure. We're talking about a sphere, right? So I can have negative values too. Okay, so if x equals 1, y is
Also negative 3. Or
3, z is
5.
5. When x equals -1, y is,
Negative 3.
z is,
Negative 5.
okay? So those are my 3 points. Now I need to figure out what the function values are, right? What was my function? 2x plus 6y plus,
10z.
so f of x, y, z was 2x plus 6y plus 10z, check.
Yes.
So f of 1, 3, 5 is 2 plus 18 plus 50, check me.
Yes.
70? And, well, it's a good thing I have 2 running in a max and a min. So this is the max, and this is the min. Wasn't that fun?
I like this way a lot better.
For this one, yeah.
Is there ever a case where you can't use one technique versus the other? Or
Yes.
can they all work?
Yes, sometimes there are. Often you'll have an example where you can do either one and one may be nicer than the other. You would not want to do this one if you had really yucky equations to solve, crazy partial derivatives or something. But for the most part, you can do either one.